Hello everyone. Good morning. I am Soumyaranjan Purohit, a faculty member in the Department of Food Engineering and Technology, Tejpur University. So today I will be speaking on fortified rice kernel in the short form known as FRK. So as the name suggests, fortified rice kernel means it is the rice kernel which is fortified with different fortificants. What are the fortificants? So it may be minerals, vitamins and other mostly the micronutrients, because the major composition of rice is carbohydrate. It has significant amount of protein, little bit of fat, minerals and moisture. But apart from that, all these five components, all these five elements are the major elements of a food. And so what are the micro elements or micronutrients in a food? So that is vitamins, minerals and other some of the phenols and other flavors compound or any other pigments also. So in this case, when along with the macronutrients like carbohydrate, protein, fat, which are mostly energy building, but mostly the micronutrients or the microelements are functional to the consumer, functional to the body. So that's why there is a need for the fortification of all this. There is a need for fortification of all these micronutrients into some kind of food that is generally consumed by large population. For example, rice. A majority of population of the country, they feed on rice, they consume rice. So if something can be fortified on this kind of staple food, so it can be a wonderful vector for the fortification, and that can reach huge population. So this fortified rice kernel is in current time in Indian scenario. Now the fortified rice kernel is most specifically, it is iron fortified rice, means the fortified rice kernel or the rice kernel is fortified with iron. So what kind of iron is actually fortified into the rice kernel? Okay, then I'll come to how to fortify the fortificant into a rice kernel. Okay, so generally for the fortification of rice, a chemical called ferric pyrophosphate is generally used. But the problem with ferric pyrophosphate is the bioavailability. In a simpler word, if I say, the usefulness of the iron or the amount of iron that is assimilated into the consumer body is very less in case of ferric pyrophosphate. And as on the other hand, the heme iron or the ferrous sulfate FeSO4, it is very easily available to the consumer if consumed. In a scientific word, if I explain, the bioavailability of FeSO4 or ferrous sulfate is more. If you compare the bioavailability of ferric pyrophosphate with ferrous sulfate, you will find that for ferric pyrophosphate the bioavailability is 20 to 50%. For example, a consumer consumed 1 gram of ferric pyrophosphate will hardly can assimilate around 0.2 gram to 0.5 gram. Remaining of the pyrophosphate will not be utilized by the body and it will remain accumulated in the colon, which is not good for the body in some sense. Okay, but if someone is consuming ferrous sulfate, so the bioavailability of ferrous sulfate is very high. So almost all the ferrous sulfate can be utilized by the consumer. So ideally the iron fortification of the rice kernel should be done with ferrous sulfate as a fortificant, not ferric pyrophosphate. But what is the reason that in common practice we prefer ferric pyrophosphate being the low bioavailability? The reason is, when you fortify ferrous sulfate to any rice kernel, it actually creates a discoloration. It will give a very dull color to the rice kernel. And number two, ferrous sulfate is very highly water soluble. So whenever you cook the rice, it actually gets leached out. It gets washed out during the cooking process. So hardly during cooking, if all the ferrous sulfate is removed, so hardly any ferrous sulfate will remain in the, or very minimum quantity of ferrous sulfate remain in the rice kernel, which will get into the body of the consumer. So to manage this challenges, so there is a need to create some scientific intervention that we can use ferrous sulfate as a fortificant and minimize the use of ferric pyrophosphate. Okay, so this is a general idea about what is FRK or iron fortified rice kernel. Okay, and this is the what are the challenges and what kind of solution is expected from the scientific community in near future. So this fortified rice kernel is generally produced by a technology called extrusion technology. So this fortified rice kernel, it's not generally grown in the farm, it is not grown on the land. It is generally produced through a machine called extruder. Okay, so maybe those who want to learn more about extruder, because it's a large subject, it's a vast subject, so it may not be easy for me to explain everything about extrusion process in a very detailed, but I'll just give a brief idea like how this extrusion technology is being used for the production of FRK or fortified rice kernel. So you can just recall, maybe in earlier time, maybe your grandma or your mother, they might be making some kind of vermicelli or noodles in home. Okay, so that you can take as an example, like some kind of dough is fed into a machine, and when you rotate with your hand, so some kind of long strands come out. So it depends what is the shape of the strand. It depends like what kind of die opening, what kind of mold you are using, that is giving a strand. Instead of a say normal circular opening, if someone is using a say star shape opening, so what will happen, you will get a shape of a star. Okay, a long strand. So from, if you see the transverse section, it will be a star shape. Okay, so if you cut into small pieces, you will get small thins, the star shape extrudate. Okay, similarly, if the shape of the opening in this system, in this small system, is just assume this opening of shape of the opening is rice shape, so what will happen, you will get, if you cut it at a similar interval or equal interval, you will get small rice like shapes. Okay, rice like kernels. It is not rice, but it is like rice, so that's why it is commonly called as rice analog. Means it is not rice, but it looks like rice. And the issue here is, sometime making when we are making in machine, one may think that it may not, why someone is calling it as rice analog, why it is not some machine based, some extruded, why to call it as rice analog. So the answer for this is, the composition of this machine based rice or this extruded rice is same as what we grow in farm, because the main raw material or the raw ingredients used for the production of fortified rice kernel is the rice flour itself. So you might be wondering that why to use rice flour, because the thing, if you try to understand here, so in the farm we generally grow paddy. We don't consume paddy, we need to process the paddy in order to make it edible. So during the process of this converting paddy into our milled rice or white rice, there is huge amount of broken rice is produced. Okay, so that broken rice is generally, in some cases, in some of the states or in some of the there are a lot of unfair usage for this kind of rice, broken rice. So what this mostly the wheat millers do is, they take the this broken rice, they flour it, make powder of it, and they generally use this as an adulterant in this atta, maida, or all kind of micronized wheat flour. So this is a huge opportunity to utilize the same rice, broken rice, make it into powder, and let us convert that flour, that rice flour, into again a rice shaped kernel. And here there is another major advantage or opportunity is, let us fortify vitamins, minerals, and other micronutrients and make a very nutrient rich fortified rice kernel, which can be blended into huge amount of normal rice. So this fortified rice kernel is generally not advised to consumed as sole. Means it's not necessary that the consumer to consume say huge amount of fortified rice kernel at a time. So the general prescription is 1%. For example, if you have a rice bulk, so out of that bulk, 1% of the rice kernel can be fortified rice kernel. So it is not that we are consuming the bulk which is processed from the extruder. So whatever the fortified rice kernel is produced during the process of extrusion, that can be added to bulk rice. Okay, and as a whole, when you are adding this into the bulk rice, that is going to give a nutrient rich bulk rice, and these single kernels are going to contribute significant amount of micronutrients or minerals, whatever you have fortified. So this is a general scenario like what is happening in India as far as FRK is concerned, and through Poshan Abhiyan to make the country anemia mukt Bharat. So the country now is giving a lot of push for this fortified rice kernel. Most at this time in 2023, most specifically it is iron fortified rice, and the iron fortified rice is generally produced by this extrusion processing, what I explained. And I think there is a huge scope for the industrial sector also to see what are the different opportunities available as far as FRK is concerned. And though there is an industrial setup is already established, but the issue of ferric pyrophosphate, how to reduce the use of ferric pyrophosphate and how to enhance the use of ferrous sulfate is definitely going to be a game changer. And in our lab at Tejpur University, we are now working on the same concept, how to reduce the use of ferric pyrophosphate and enhance the use of ferrous sulfate in order to gain maximum bioavailability of the iron and avoid unnecessary addition of huge quantity of ferric pyrophosphate. So I hope I gave you a general idea about fortified rice kernel, little bit about extrusion processing, what is going on in and around India as far as the iron fortification program is concerned. And so thank you all. That's all from my side for this episode. So in the next episode, I'll try to bring some more information on this, and I hope we'll communicate further. Thank you.